Hello class, we are continuing on with this first unknown resistor. If you remember, we have our voltages here that we changed, and we have our corresponding currents to each one of these voltages. And so let's see, the next thing that we want to do is we want to actually generate a linear equation right here. If you guys can see this, y is equal to mx plus b for Ohm's law. So this warrants a small bit of discussion. I'll just go to this handy app here. And let's see, maybe here. Okay. And the small bit of discussion is going to be based on y is equal to mx plus b. And so we are going to put what's on the y, whatever we choose to be on the y-axis will correspond here. Whatever we choose to be on the x-axis will go here, okay? And the slope will be just the rise over the run. So what is the rise? The rise is y, or delta y. And what is the run? It is delta x. So let's choose our voltage to go on the x-axis and our current to go on the y-axis. So if that is the case, then we'll have m is equal to the change, is that right? The change in current over the change in voltage. I don't think that's what we want. Nope, we don't want that. So I'm just going to strike this out. Let's go ahead and put m is equal to the change in voltage over the change in current. We could do it the other way, but I just want to skip a step. There'll be an inversion step. So if we put voltage over here, and let me take that delta out, just voltage here and put current here, then we're going to get a straight line. And remember that the slope of this line is going to be delta V over delta I. And so that's going to be M. And M is just going to end up being R. According to Ohm's law, R is equal to delta V over delta I. So we'll be able to solve for this. Also know that B is just the y-intercept. It's where this line is going to cross the y-axis, where it's going to intercept the y-axis, or where it's going to intercept the y-axis when, in this particular case, our current right here is equal to 0. All right? So it's what the voltage is going to be when the current is equal to 0. So now that we have that, let's just go ahead and go back here. What we want to do is we want to put these numbers in this table right here into Graphical. So I'm just going to go ahead and go to Graphical. If it's already open here. Let's see. Nope. So, and in Graphical, I'm going to go ahead and create an experiment. And we're going to use manual entry here. So in this manual entry, we can change our x. We said we wanted our x to equal to the current. And we're going to make this amps. So those are our units for current. And then we want our y to be voltage. So now we are going to go ahead and put in our numbers for current and voltage. So the first one was 0.0019515. at 2 volts. That was our amperes at 2 volts. Our amperes at 4 volts was our amperage at 6 volts is and then our amperage at 8 volts is 0.007805. And then finally, we have 0.009756 amps at 10 volts. So now that we have this table here, we can just go ahead and draw a graph by selecting on our wrench here and choosing one graph. And you'll notice that all the points are on the side here. So all you have to do is just double click here, tap on your screen. And when you tap on your screen, things will be auto scaled for you. And now we want to go down here, select this point, just tap it once. And when you tap it once, you'll notice there's a tag here and there's a tag here. It's letting you know the amperage and the voltage. So let's just go ahead and select. So remember, our voltage is on the Y and our amperage is on the X. Let's just go ahead and select 2 volts, or just I want you to grab this. I want you to tap on this and then drag it all the way across the screen. All right. So we're going to go from 2 milliamps to 10 milliamps. Okay. So let's go ahead and we can put statistics on here, but I'm more concerned with the curve fit. And the curve fit is linear. Okay. So once we do that, we'll see that we have our M here, and our M corresponds to the slope of this line, and that's just our resistance. So our resistance in this case is 1,025. So we can just round up 1,025. And if I remember right, that was what we chose our resistor to actually be. So I'm going to go ahead and go back and put that in. And I'll just check it. All right. Then I'll go to the next one. But that's it for this video.